Welcome. So now we're going to be finding we're using the chain rule with graphs and tables and diagrams. And this is our first one. And it's always really, really, really important to read the question on these. And I say that because it's easy to look at the graph and say, I'm looking for a tangent line. Right? A -4 slope of the tangent line, that's a line. That's easy to find, that slope. And not happen to notice that the graph is h of x, and we want to find the equation of the tangent line to the graph of p of x, which is the square root of h of x, when x equals -4. So you got to be really careful with that. Make sure you figure out what they're asking you for. All right, so p of x, right, is going to be this function here, the square root of h of x. Right? So we're not even going to look at that graph until we take the derivative, and then using the chain rule, and then we can go to our graph to get some information. All right? So p prime of x, right? So we can, by the way, write that as, oops, well, that's not what I wanted to move. I wanted this to move, because I need a little bit more space. Okay, that still worked, I guess. So we could rewrite this as h of x to the 1/2 power. Right? And so the derivative, exponent moves in front using the power rule there, 1/2 of h of x to the -1/2. That would be that derivative. But then it's a composite function. H of x is a function too. So then we have to multiply by the derivative of h of x, right? And that's just the chain rule. Right? So we take the derivative of the function, and then we take the derivative of the inside part, right? So if you have a composite function, right, you have to take the derivative of the outside and the derivative, oh, almost had enough space, of the inside. Well, isn't that colorful? I have no idea, by the way, how that occurs. Just sometimes it decides to break up my words into tiny little pieces. All right, so now let's figure out the rest of this here. All right, so we have p prime of x is, let's clean this up a little bit. All right, so the h of x to the -1/2, that's going to go to the denominator, as is the 2. We could rewrite this as h prime of x divided by 2 times h of x. Really do need an extra parentheses in there. And that would be, we can put that back into a radical, right? Square root of that. All right, so now let's find all the parts using the graph, right? Now that we wrote the derivative, right? So step 1 was find the derivative. It's always best to just not worry about values until you find your derivative, right? And that was using the chain rule. Step 2, use the graph to evaluate. And we're evaluating the derivative. And in this case, we have a step 3 because it said equation of the tangent line. So step 3 is write the equation of the tangent line. So the p prime of x, that's our slope. And then the point, when x is -4, y is 4. Right, so, and then -4, 4, that's the point. All right, so now we just need to evaluate. We're on step 2, and then we can do step 3. All right, so p prime of, and we're looking specifically at -4. Now we've got to make sure we choose the right values. If it's an h prime of x, its slope. And if it's an h of x, it's just the y value. Right? Value of the function. That's supposed to be y in there. Right? Right? So we have p prime of -4 equals h prime of -4 divided by 2 times the square root of h, just in parentheses there too, h of -4, right? Now p prime of -4 is h prime of -4, that's the slope, right? And thankfully it's that linear part, right? Because that's what a derivative is, right? Derivative equals the slope of the tangent line. All right, so our derivative, our slope here, if we look between we look between those 2 points, our slope there is -1/2. Right? So that's what h prime of -4 is. Matter of fact, it's -1/2 if we had chosen anything from 2 to -6. Right? So the h prime of -4 part, that's just -1/2. Right? All right, now we need the rest of it. All right, so 2 times the square root. H prime of -4, it's right there. Right? And I'm fixing the 4. That's 4. Right? It's the value of the function when x is -4. And the value of h of x when x is -4, that is 4. All right? So it's really, really important, by the way, can't stress that enough, that you read that really carefully so you know what's pictured and what you're supposed to do with it. All we got to do now is simplify this, and we're done. All right? So I'm going to write this as 2 fractions. So this is -1/2 dividing by 2 square roots of 4, or we should probably simplify the square root of 4, is the same as multiplying by 1 over 2 square roots of 4. And the square root of 4 is just 2. All right, and so that's going to give us -1/8. So p prime of -4 is -1/8. And we're almost done. So this was the step 1. And this is the step 2 where we evaluated. And step 3, I wrote kind of big. And I gave myself very little space to write the equation. But fortunately, I'm just going to extend that page just a little bit. There we go. We don't need very much space to do the last part. All right, so step 3, let's write the equation on the tangent line. We've got the point, we've got the slope. That's just going to be y minus 4 equals -1/8 x plus 4. And let's isolate the y. And you can distribute if you want and put it in slope-intercept form, but I'm totally fine with this. All right. Now, if you're taking a multiple choice test, then it's in slope-intercept form. Of course, you'll have to simplify it. And that's not that big a deal to simplify this, but I'll just leave it just like that. And there we go. Problem number 1 has been solved. All right, and this is a really good problem because they like to put problems like this, where you've got a graph of one function and you got to use that to find some information about another function. In this case, we're finding a tangent line of a composite function where that's the inside part. Right? So that graph there, this is the graph of h of x. Another good idea is to label your graphs. Right? And that's the inside. That's the inside in our function here. All right, let's solve another one. Moving right along here. This one's actually not a very long lesson. It's only 7 slides. And of course, hopefully they all won't take 9 minutes. All right, so now let f of x and g of x be differentiable functions such that the following are true. Is the graph of f of g of x increasing, decreasing, or at a relative max and minimum when x equals 3? And give a reason for your answer. So we're going to have to evaluate. We're going to have to find the derivative. We're going to have to evaluate it, right? And then we're going to need to figure out what's happening, right, to our derivative at x equals 3. All right. So always write your formulas on these. So h of x equals f of g of x. H prime of x is going to be the outside function, the derivative of the outside function, so f prime of g of x times the derivative of the inside function, g prime of x. All right, so now let's evaluate it. It's at x equals 3. So h prime of 3 equals f prime of g of 3, g prime of 3. Now, I lost a parentheses there. All right, so you're going to, so remember, if we're evaluating, right, we do inside and then outside. Take the derivative, you go outside in. When you evaluate, you go inside out. So you're going to have to evaluate here first. Because I don't know what to take f prime of, right, until I know what g of 3 is. So find g of 3, and then you'll know what to do with f prime. All right, so h prime of 3 is f prime of, so g of 3 is right there, is 4. We may as well replace g prime of 3 while we're at it, and then we'll take care of the f prime of 4. So g prime of 3 is over here, that's 6. All right, so g prime of 3, that's 6. And now f prime of 4 is 8. All right, so we've got h prime of 3 is 8 times 6, which is 48. I'm going to have to write wherever I can find space. I can't write smaller with these pens. So I'm going to write above. All right, so relative max or minimum. All right, so that's a no there, right? So relative max or minimum is going to occur where you have horizontal tangent lines, right? So h prime of 3, actually I'll make it a sentence. Since h prime of 3 does not equal 0, all right, x equals 3 is not a relative max or min. I don't think it'll take us as much space to answer the next question, so I'm just going to keep going wherever I find space. Is not a relative max or min value. Right? So it's not that. It is greater than 0, right? So I'm going to write a different color here. So here's part 1 of it's part 2 of my answer. So since h prime of 3 is greater than 0, h of x is increasing at x equals 3. All right, so that's what it is doing. All right, so increasing or decreasing. This one's a yes, but the relative max and min, that was a no, right? Because it's not a horizontal tangent there. So it can't be a relative max or min. All right, so now let's answer the next question. If p of x is equal to g of 2 of x, what's the value of p prime of 1? All right, so we have a composite function. I'm going to erase this so we don't get confused. Now write in a new color. All right, so p of x is g of 2 of x. That's a composite function. You need to use the chain rule. Every time you see a composite function, you think chain rule if you're taking the derivative. All right, so we have p prime of x is going to be the derivative of the outside, so g prime of 2x times the derivative, that means take the derivative of the inside, which is 2x. Right? So let's just simplify this a little bit with the x's, and then we'll plug in the 1's. So p prime of x is equal to g prime of 2x, and then the derivative of 2x, of course, is just 2. Okay? So then we're going to multiply by 2. All right, so g prime, now let's evaluate. So we have p prime of 1 equals g prime of 2 times 1, and then times 2. All right, so that's g prime of 2 times 2. G prime of 2, oh, here it is. Is right there, it's negative 1. So p prime of 1 is negative 1 times 2, which is negative 2. Okay? And had they asked if what's happening here, that one would be decreasing. Right? So there, p prime of 1 is negative. Right? So that means p of x would have been decreasing at x equals 1. Right? But they didn't ask us. Right? So that one was decreasing because the derivative is negative. Right? Because if your slope, derivative is slope, and if your slope is negative, right, the function is decreasing. All right, so now let's, same table, new set of functions. Well, that page only took me, actually I did 2 pages in 7 minutes, didn't I? All right, so now let f of x, and no, I only did 1 page. Oh well, I'm working at 8 minutes a page. So let f of x and g of x be differentiable functions such that the following are true. Same one as before. Let q of x equal the square root of f of x plus g of x. What's the value of q prime of 4? What does this value say about the graph of q of x when x equals 4? Give a reason for your answer. All right. Again, a composite function. Right? The outside function is the square root. Right? And then the inside is the f of x plus the g of x. Right? So we have our derivative, q prime of x, is going to be the derivative of the outside. Actually, let me rewrite that as a, so we can use the power rule. So q of x equals f of x plus g of x to the 1/2 power. So q prime of x is 1/2 times f of x plus g of x to the negative 1/2 power, right? Because 1/2 minus 1 is negative 1/2. And then we need the derivative of the inside, right? Because this is a chain rule. Little reminder there, chain rule. Right, so we need the derivative of the outside times the derivative of the inside. That's the easiest way to write that. All right, so the derivative of the inside, well, that's just a sum, right? So derivative of a sum is just the sum of the derivatives, right? So that's just the sum rule. So we're going to multiply that by f prime of x plus g prime of x, right? Because we just have the derivative of a sum. That's right, derivative of sum equals sum of the derivatives. All right, let's clean this up, and then we'll plug in. All right, so q prime, and then we'll answer the question. Q prime of x equals, all right, so you're going to have f prime of x plus g prime of x in the numerator. And in the denominator, it's going to be the 2. And I'm going to change that back to a square root. I kind of like square roots better. F of x plus g of x. All right, so now we want to evaluate for x equals 4. All right, so q prime of 4 is f prime of 4 plus g prime of 4. By the way, I dropped the parentheses because now the fraction bar is serving as a grouping symbol. I don't really need them. That whole thing is being divided by 2 and by the square root there. All right, and so divided by, but that's a little too long of a fraction bar, divided by 2 times the square root of f of 4 plus g of 4. Let's hope it's a perfect square. All right, so that's going to give us q prime of 4 equals, All right, so f prime of 4, where are you, is 8, plus g prime of 4 is negative 2, divided by 2 times the square root of f of 4 is 1, and g of 4 is 7, so not a perfect square, but we could simplify it at least. So q prime of 4 is 6 divided by 2 times the square root of 8. 2 times the square root of 8 is 2 square roots of 2. All right, so I'm just going to kind of simplify it. And see if I'll squeeze it in. Q prime of 4 equals, oh, and then actually, what? Forget this simplifying. Let's divide first. Let's reduce. Then let's pull out the square root of 2. So that's going to be 3. So it's going to be 3 divided by 2 square roots of 2. I don't care if you rationalize it. It's not a big deal to me. There is our derivative. And what does the value say about q of x when x equals 4? And I'm going to step back just for a moment and just make sure I didn't make an error anywhere. It's kind of a strange number. I guess it's not that strange. Yeah, there's a 2. Yeah, I don't see anything wrong. And I didn't manage to, and I plugged in the right values. 8, negative 2. Yeah, that's a 6. And yep, that looks okay to me. So it's positive, right? So what does it say about q of x? So q of x is increasing when x equals 4. Oops, not q prime of x. Now, my hand did not listen to me. I told this to one of the other classes. Sometimes I'm writing one thing. Maybe I said q prime of x, but I'm pretty sure I said q of x. Q of x is increasing when x equals 4 because, actually, here's a symbol for because. There we go. Because q prime of 4 is greater than 0, right? So if your derivative is greater than 0, it means your function is increasing, the original function, right? Because the derivative gives you the slopes, right? And if our slopes are negative or positive, right, then we're going to be increasing, right? And that 3 divided by 2 square roots of 2, that is a positive number. All right, continuing on. All right, so I know I have 4 pages left. There's 4 little problems here. We want to find the following limit. And actually, I'm going to split this podcast in 2. All right, so I'm going to pick up with the last 4 problems. This is a good place for me to end one podcast and begin the next. All right, bye for now.